This conference will now be recorded.
Just a quick word on Ricardo, who may be new to some of you as far as the railway industry is concerned. You may very well be aware of Ricardo's very long background in automotive and military, given that Ricardo started off by developing the tanks in the First World War, the transmission systems for them. It's mainly associated with systems on the railway side, but it is a worldwide organisation. There's over 600 people and less than a quarter of those are in the United Kingdom. So the infrastructure asset manager's version of Kipling's serving men. Well, Kipling's rhyme is, I keep 6 honest serving men. They taught me all I knew. Their names are what and why and when and how and where and who. I don't exactly use those questions, but I do use ones that can be related to those, and you'll see the full list as we work our way through. So, starting, what's out there? And my first example is from the early days of the London Underground PPP, public-private partnership contracts, where I had drafted the track asset part of the public-private partnership contract. And for the first few years, London Underground used me to review the asset condition assessments that the 3 infracos submitted. And a few years into into the PPP contracts, one of the infracos, in its annual asset condition assessment, said that a particular track form had been wrongly recorded over the years and that they were now updating it to reflect what the record should say. And I found this interesting. And as it happens, I had sat opposite me a gentleman who had, as a student, worked on that section of track. So I said to him, David, what's the track form at X? And he told me, and it was the same as had been the way it had been recorded, and not the way the infraco was saying now. I said, are you sure? And he said, I'll go up in my attic and get the photographs if you want. So I said, fair. So we went back to the infraco and said, are you sure? And they came back and said, yes, it's been wrongly recorded all these years. So I went back to David and said, are you sure? And he said, yes, I'll go up in my attic if you want. Rather than doing that, we actually sent somebody to have a look. And he came back and said, David's right. So we went back to the infraco and said for the 3rd time, are you sure? And they came back and said, why are you asking this? We have told you already it has been wrongly recorded over the years. So on the basis, if we didn't trust their assessments for what we knew, how could we trust what we didn't know was wrong? We rejected the annual asset condition assessment for track, which meant that the whole of the annual asset condition assessment for that infraco failed for that year. And it was interesting, the asset management people were quite cross about this. And they said, but we gave you assurance. And we said, but it's wrong. And they said, but you're supposed to be accepting our assurance. It's an assurance-based contract. And we had to point out that London Underground is the ones with bottom line safety of line responsibility. Another example is from Tramway. Now, a couple of years before this incident, I'd been acting as a reviewer for reviews of a minor design change to the layout, basically moving a set of switches from one side of a road to another. So I was pretty familiar with the layout, and I was asked to do an independent review of a proposal to change the control arrangements. And the more I looked at this, I thought the diagrams that go back to the original design don't match reality. The distances between the roads is completely wrong. You'd get several trams between the roads rather than just one. And there's pedestrian crossings there that I'm sure don't exist. I was so puzzled, I went to have a look because it was quite easy to do. And that confirmed that the diagrams bore no resemblance to what was actually on the ground. So I went back to the tramway concerned and said, look, before even playing about with thinking about changes control arrangements, what you should be doing is validating what you have as design and as built information. And you could start by looking out your window, because you could see by looking out the window of the office that what was on these pieces of paper didn't match what was out there. What does it do? One that seems to catch people out is the top of cuttings. Now, if you think about when a railway is built, the cutting cuts through the general lie of the land, and the water that used to run down the slope has to go somewhere. And our Victorian forebars, the good ones, built interceptor channels along the tops of the banks. The trouble is it's not very visible to the patrollers, particularly if the bank's got vegetation on it, and people do tend to let them get full of detritus, dead vegetation, and you name it. But it's understanding what it's there for. And there was a recent rail accident investigation branch report for Watford Tunnel, where the spillway associated with the interceptor channel hadn't been recognised as such, and it was actually treated as a structure supporting the cutting slope. Because nobody realised it was part of the drainage system, the channel overflowed, flowed down the bank, and the earth finished up on the track, derailing a train. Another example from the tramway world is groove rails and what's known as the keep on a groove rail, which is the piece of metal on the opposite side of the groove to the running head. And heavy rail people tend to think it acts like a check rail. It doesn't. It's not strong enough to act as a check rail, and you can't repair it readily because it's so thin. What it's there for is to stop the road surface finishing up in the groove, particularly if it's a soft rail surface, a road surface, or in the old days, if it was a non-tarred macadamized surface when there was very little holding the road together. What does it interact with? Cross-functional interfaces. A light rail system that I've been associated with had very light bridge decks. Because they've been designed for light rail loadings, they were far less stiff than a heavy rail bridge would be. And if you've got 30-meter spans with a thin concrete deck supported by two 30-meter plate girders, each with a simple rubber bearing at each corner with little cross bracing, you get an awful lot of deck vibration. Now, the structural engineers had looked at this and said, there's no problem, it's not going to fall down, it's just interesting, it vibrates. The problem is that on the deck is switch and crossing work, and the point operating equipment doesn't really like vibration. And when you have stretcher bars holding switch rails where the switch flangeway gap is tight and the wheels, the backs of the wheels are striking the switch blades, the stretcher bars don't like it. They're vibrating and they're being hit and they break. Not good. Another interaction problem is earthing and bonding of metal structures. And there is a major London station where they got this wrong, where the metal covers on the platforms were at a different potential to the trains with the electric power going through the trains to the rails. And they found out when they put a wheelchair ramp on the train and it touched one of the metal plates on the platform and spot welded itself to the platform. The way to do it right was shown at the Edinburgh Gateway, which is where Edinburgh Tram with DC overhead and the mainline railway station AC ready. The designers took very great steps to make sure that there is no way that any metal that's at the same potential as the tramway cannot be touched at the same time as any metal with the same potential in the future as the AC system and the main line. And given there's lifts and escalators, etc., that was really well done. What are the key risks? Well, Obviously, it's determining things like serviceability limit state and ultimate limit state. And I'll refer you back to the light rail bridge, where the key risk was actually the serviceability limit state. Going back many years to my days with HM Railway Inspectorate, I was HMRI's representative on the Department for Transport's Bridge Bashing Committee. And at those meetings, you had department people, highways agency people, whatever the name was then, Road Haulage Association, local authorities, rail track, you name it. And everybody was generally agreed about things, except for the gentleman from the Health and Safety Executive, who took great umbrage about the possibility of goalposts on advanced to low bridges, because he said, what happens if a hay cart comes along and knocks the hay off onto a pedestrian? And we could not get it over to him that there were two problems. First of all, if the goalpost wasn't there, it would simply do it at the bridge. And secondly, if you had a high load, there was a very real danger of moving the bridge on the abutments and causing a major derailment. But we just couldn't get over to him that the hay falling at the goalpost was not the key risk to worry about. And the third one in this one is one where I have been jeered at the Institution of Civil Engineers, is the inspection and maintenance of bridge abutments. Now, many of you will know the problem with bridge abutments is they do tend to attract pigeons. And over the years, it can be a disgusting mess that you may even require biological warfare type of kit to clear out so you can do a root and branch examination of the bearings. And I pointed this out at a designer's session, and the designers simply did not think that this, a key health and safety issue for the ongoing inspection and maintenance of the bridge, was anything to do for them. In fact, it was even worse on Edinburgh Tram, where the local council's environment people wanted to use the bridge holes for bat nesting boxes. And this affected both the tramway, where I was independent competent person, and other bridges. And together, myself and the council engineers pointed out that you had to be able to go into those bridges. Just you could not put in there a heavily protected species that prevented you from disturbing them to do that. And from a health and safety point of view, the last case of rabies in Scotland in the 2000s was actually from a bat bite. And this was what they were hoping to put under the bridge holes. What are the critical limits? The maintenance threshold might be 90% or better. The maintenance limit may say this should not be worse. The safety standard will say this must not be worse. The first two are management tools linked to reliability and frequency of condition information. The last, the safety standard, requires mitigation. What condition is it in? But this is purely a snapshot. It is 1 point on a degradation curve. How fast is it deteriorating is the key question. Take rail wear. Side wear of, say, X millimeters on the Chesham branch and London Underground may mean years of life. Side wear of X millimeters on the 60-meter radius Caxton curve on the Central Line may mean that a speed restriction will be needed by the end of the week. Degradation is so rapid, replacement should have been planned already. Does it matter? Do you understand the risks associated with the assets and the interfaces? What could happen? How likely is it? Then you know if it matters. Do you know the true cost of getting it wrong? Both the United States National Transportation Safety Board and the French equivalent, BEATT, include repair costs in accident reports, but not loss of track access charges, civil damages, etc. So Railtrack let RT1A maintenance contracts for each of the 25 or so of the old British Rail areas. They were not the same. At least one did not include rail lubricators. The contractor's contract management team told the maintenance engineer to stop maintaining him. So he did. What happened? Well, the train wheels and rail both started to wear very quickly, to the extent that the train service was seriously affected by units stopped for tyre turning. People are still getting it wrong. Visual inspection and non-destructive testing are key elements of risk mitigation. But it needs to be done by competent people who know what to look for, who can report what they find, who have adequate track access, who cover the full extent of the inspection at the correct frequency. And of course, there's competent management to interpret and action the findings. Hatfield 2000. The rail was known to be in poor condition. The rail was known to be untestable. It was known to have unsatisfactory access for inspection. The knowledge of crack growth risk in mill heat treated rails had been lost in Railtrack, although it was in the Permanent Way Institution textbook. There was only one in those days, not a set of 10 volumes, but it was clear in the Permanent Way Institution textbook. There's a crack growth risk in mill heat treated rails. The longer term benefits of rail grinding were not quantified, so on cost grounds, it was no longer carried out, and rail replacement was planned but deferred. Grey rig. We had a poor setup of points. Repeated visits were finding switchback contact, which goes back to our light rail example again, where there was switchback contact causing problems for the point operating equipment. In this case, the repeat maintenance visits were finding loose components. Came the day when a visual inspection did not cover the correct area, the components came free under a train with fatal results. It's not just here. Bretigny in 2013. It's a known difficult location, as you can see, with reduced asset life, a complicated track layout with many components. There's heavy traffic affecting the quality of inspections, staff repeatedly having to stand clear. There was no increased surveillance. The bolts were not regarded as a critical asset. And there was no spanner for many of the specified torques. In fact, in the past, this was a London Underground issue as well, where there were 7 or 8 different torques, but only 2 different spanners that weren't adjustable for the different torques. And as you can see in this example, limited visibility of bolts in the forefoot. There were organizational issues. Asset management. The RFF, the then French equivalent of Railtrack, imposed productivity requirements without considering practicalities, basing decisions on economic logic and on the lowest immediate cost. Planning. Aging infrastructure meant more reactive repairs at the expense of planned maintenance. Organization. Staffing reductions were not related to local risk mitigation needs, and there were difficulties in filling the remaining skilled posts. In fact, the safety culture had been eroded. Lookouts were assisting in work because the gangs were too small to carry out activities. What happened? Well, loose knots caused the fish plate holes to fret under dynamic track movement. The patroller, although acknowledged in the accident report as being very diligent and finding remarkable things, as many of us know patrolmen do spot, he did not observe the problem with the bolts. The fish plate broke up under a bolt hole under a train. The remaining part rotated, as you can see in the right-hand photograph, and lodged in the flangeway. A Collie train travelling 85 miles per hour derailed. There were 7 deaths. Interestingly, 4 of them were actually at the station rather than on the train. The Netherlands. ProRail, the Dutch network rail, let performance-based contracts. There were standard track designs from ProRail, but ProRail only provided limited track maintenance standards. Most maintenance standards were prepared by the contractors. There was no risk-based assessment of failure. Switchback contact was not seen as a risk, and track access was limited to minimize disruption. Well, where have we heard that before? ProRail itself had a hands-off approach. Switch wear and similar problems did not cause immediate disruption. When there was a change in contractor, the switch conditions were not reviewed. Indeed, contractors were monitored by returns, not site data. ProRail had no knowledge of actual condition. Switch wear was associated again with wheels striking open switchbacks, imposing unplanned loads on the locking equipment. So yet again, we've got an example similar to my light rail one earlier on. There was a curiosity with the design of switches and their risk assessments. There was a perceived risk in the Netherlands of run-through derailments if you trailed through a set of switches and the wheels didn't force the switch open, but rose up and over them. So all designs of switches included a split ring. Even the facing points not normally trailed included the split ring. The split ring should not be taking routine load. But the switchback contact meant that impact loads were being imposed and the split rings were breaking under those impact loads. Well, the unexpected loading was not investigated by ProRail or the maker or the contractors. The maker redesigned the split ring without querying failure cause. And to add to the problems, there was poor manufacture of the ring with stress raisers. So the split ring failed in the facing point in the bottom right, the switch blades were not connected, and the train went both ways, as you can see in the background, fortunately with limited casualties. So I'll summarize the serving men. What's out there? What does it do? What does it interact with? What are the key risks? What are the critical limits? What condition is it in? How fast is it deteriorating? And does it matter? Well, so far I've covered the United Kingdom and a couple of our European neighbours. The next example comes from one of our pretty dodgy former colonies. I mean, these people fight and scream to get independence, and what a mess they make of it. In the US, the Federal Railroad Administration has a very hands-on legal ability to oversee what the heavy rail people get up to. The Federal Transit Administration is one step removed. It authorizes the state oversight bodies. The trouble is, in this case, there isn't a state oversight body because it's Washington, D.C., the Commonwealth of Virginia, and the state of Maryland. So it has a separate oversight body that almost has a season ticket for National Transportation Safety Board investigations. They do not have a good record. In 2015, the track recording vehicle ran on the 9th of July 2015. The gauge was over 3/4 of an inch above safety limits. Immediate removal from service was required. No action was taken, and there was a derailment due to wide gauge on the 6th of August 2015. A special safety oversight investigation, in addition to the National Transportation Safety Board investigation, was launched. There was another derailment on the 29th of July 2016, also due to wide gauge. The gauge was 1 3/4 inches above immediate action limit. 16 of the 18 bearers were defective in the turnout. 400 inches, about 10 meters of rail was unrestrained by fastenings. Inspection was required twice weekly and was being carried out monthly. There were 16,828 outstanding track defects on the system. The gauge ties in this photo were added after the derailment, but what I would draw your attention to are the spikes. It's not very clear what purpose they were forming. So the Special Safety Oversight Investigation reported on the 8th of August 2016, immediately after the 2016 incident, and I've put their findings out in full because it's the only way of indicating how badly things can go wrong. The track inspectors receive inadequate training. There is insufficient time for track inspection. Excessive wear and deficient bearer condition in junction work is not being identified and addressed. The track geometry vehicle is underutilised as part of the track inspection programme. Yep, it goes on. The Track Maintenance and Inspection Manual is not a field document focused on inspection safety limits. There is not a clear process in place for track inspectors and supervisors to impose and remove speed restrictions. There is a failure to use inspection data to inform and prioritise track maintenance. Maintenance managers require additional training and resources to act on inspection data. Current inspection and maintenance activity does not adequately address tunnel drainage systems, not good for a system that has an awful lot of underground within Washington, DC itself. Additional supervision is needed for both track inspection and track maintenance. The same quality control testing program is not used for direct labor install fastenings that would apply to those installed by a contractor while building a new line segment. In fact, you wonder if there's any quality control given the fastenings we were looking at in the earlier slide. And in certain industries, welding practices are used which are inconsistent with the construction standards. And those of us old enough to remember Bushy will know that's something that you cannot afford to get wrong. So, in summary again, what's out there? What does it do? What does it interact with? What are the key risks? What are the critical limits? What condition is it in? How fast is it deteriorating? Does it matter? Well, this is actually my 49th year in the industry. A couple of highlights. The first one was a barrister explaining after the trial why she did not cross-examine my expert evidence destroying her case, because she'd made suggestions in mitigation, and I was put up in the witness stand and basically demolished them. And she said, when I was chatting to her afterwards, that our experts said it was unchallengeable. But the thing that was really good and really made me pleased was I'd actually produced an expert report with technical evidence about overturning and derailment. And she said, even I could understand it. And this was the Maidstone East derailment in 1993 with the boozed up driver who came through the station on its side in the loco, taking away the canopies on the down platform at Maidstone East. Another highlight was actually being blacklisted by Railtrack for refusing to work for them when they wanted me to. And what they said was that if I wouldn't work for them when they wanted me to, that I wouldn't work for them when other people wanted me to work for them for Railtrack. In reflection, I think that's a good position to have been in. Right, so I conclude with a mystery photograph, and I'll pass on to Colin to open for discussion, comments, etc.
Thank you for that, John. That was informative and insightful in equal measure. Very interesting, thank you. So if there's any questions, observations, comments, please, you can either put them in the chat, or as we have a relatively small group, if you just want to unmute yourself and ask the question directly, then please feel free to do so.
Hi, Colin. It's Jordan Faulkner. I've got a question. That's okay.
Could you speak up, please?
Yeah, sorry, my microphone was on the top of my head. Yeah, it's Jordan Faulkner. I was just interested in your comment you made regarding the Maidstone East derailment.
Yes.
Not one I'm personally aware of, but sort of very close to home and areas of track I've looked after. Is that report available anywhere? Would I be able to read that?
It's vaguely available. It was at a time when HM Railway Inspectorate was part of the Health and Safety Executive, and at the time they were reluctant to publish much in the tradition of the old Railway Inspectorate reports. I think there is a report out there, but it's not greatly there's not a great deal in it. I mean, basically, it was a criminal offence. The driver, not to put too fine a point on it, was blind drunk. What was very interesting was working with the British Transport Police, who actually put together a calendar of his pub crawl, a scheduled timetable of his pub crawl during the day before booking on duty. He had been under very strong suspicion, and one of the questions I was asked was, why didn't the railway do something about it? And I pointed out that they had followed a certain piece of guidance about how you manage potential problem drinkers. And I was asked, well, who wrote that? And I said, well, actually, it's the Health and Safety Executive. They're actually following HSE advice on how to manage people in this situation. In fact, they were actually pushing it a bit, in that they were actually setting traps to try and catch him, which they shouldn't have done. But I mean, basically what the question was what speed was he going? Because the defence was trying to say, well, there might have been other issues, you know, was the track at fault, was the train at fault, etc. And what I had done from the HMRI side is provided the British Transport Police with an overview of the evidence and set it out in very simple terms with some A-level maths formulae to demonstrate, you know, that the Derby research work on the speeds and that sort of thing.
Okay.
but that didn't appear in the fairly thin report because it was a criminal offence. It didn't get quite the same accident report as perhaps other ones would have done.
Okay, great. Thanks very much. I'll have a dig around, see what I can
Yeah,
find.
if you
Thank you.
put Maidstone East derailment into Google, you will get things up for it.
Yeah. Okay. Thanks very much.
Hi, John. We've had a couple of questions appear in the chat. I don't know if you have visibility of them, or would you like me to read them out?
They've only just appeared now. Right. Okay. If they're both from you, Phil, then fire away.
Okay, so Andrew Thornton's asked with regard to slide 39, is this a dual gauge yard with locos of one gauge shunting both sizes of stock, or is it a manufacturer's test track?
It is in fact dual gauge, but there is a curiosity about it compared with normal dual gauge track. If you think about how is dual gauge track normally done?
Doesn't it normally only have one running rail on one side and two running rails on the other side? This one's got two on both.
Exactly so. Now, why does anybody think that it's got this?
Is it due to the overhead wires?
No, there's no overhead wires.
Okay.
It would work if there were overhead wires, and that's actually very close to why it was done.
Is it because of gauge, John? Maybe some structures that it needs.
No. In fact, you were very close to it with the question you asked when you were talking about the loco.
Oh, that was Andrew, was it? Yeah.
Well, it was. You said it was in the query. Yeah.
Is it a dual gauge train? So you've got the loco at one gauge and the train at a different gauge. So in order to keep the draw gear central, you've had to have running rails either side.
Exactly so. It was built as a standard gauge railway in the 1840s, and then in the 1890s it was overlaid by a large meter gauge network. But the traders on the standard gauge railway didn't want to have to transship freight at the mainline junction. And so it was laid with dual gauge like this, so that when the narrow gauge locomotive arrived from the coast, it's actually Chemin de Fer de la Baie de la Somme, so just down the coast from you people in Ashford. When the train arrived from the coast at St Valery, it could collect standard gauge wagons, and the meter gauge loco could pull the meter gauge wagons and the standard gauge wagons to Noyelles on the Nord main line between Paris and Calais, and shunt them across, and the standard gauge wagons could then be taken wherever else in Europe they were needed. So it's an unusual but very, very appropriate solution to a particular problem. As you can see, though, it doesn't half lead to a permanent way nightmare.
Okay, I have another question. This one's from Peter. Peter's asked, fine presentation, thank you. Do you find pigeon chests, in inverted commas, arrogant managers, are a rather large part of the problem of poor maintenance / inspection?
Yeah, one of the problems I've found is getting people to understand that projects are not the be all and end all. And you need to think about the stuff that's going to be maintained for, particularly for track and civils, the next 30, 40, 50, 100 years. And people just don't focus on it, and they don't, even on projects, they don't focus well on assurance of the maintainability and operability of what's going to be done. It's very much a case of digging holes, pouring concrete and disappearing. And then even when you have a railway or a tramway, people are very much interested in the next project, and the politicians often simply want to have a ribbon to cut so they can get their picture in the papers. Sometimes you actually get politicians who are helpful in steering people away and letting you get on with it. And I would say that the people we had at Edinburgh for the Edinburgh Tram, the chief executive and the convener there, were good at fending off people and allowing things to go forward as the thing was being built. So I was quite happy they took the opportunity to get their photograph on the in front of the first tram with myself, the test engineer and the assurance engineer, because they had, if you like, in the background been helpful. But it's reminding people that it's there, you're there to run a service, and the asset needs to be able to support that, and getting people to understand that that's what it's all about. And one of the things that's worrying me at the moment is the number of projects where demonstrating assurance is given to the design and build contractor who doesn't have a clear view of interfaces. So if they're building a station, they don't understand about the effects of dwell time on level crossings in the vicinity. They don't understand about potential effects of lighting on drivers looking at monitors, all this sort of thing. Despite the fact that the PRM technical specification for interoperability includes ticketing, will say, well, it's nothing to do with us. And the answer is, well, if you want this station authorized, it's got to go in the notified body technical file, and it goes to the ORR for authorization. If it doesn't have the ticketing, it's not going to get it.
I think obviously for the heavy rail projects, it's a little bit more difficult, but I was just reflecting back on things like the Docklands Light Railway, where they had a build and maintain contract. So they built an extension to the DLR, and the contractor was then responsible for, say, 5 or 10 years in maintaining it. So he wasn't,
Yes.
you know, just finishing the job and disappearing. He had to plan in, you know, well, hang on, I'm here for another 10 years once this is finished. Let's make it easier for ourselves. And I think there's some merit in that. Obviously, it's difficult to do it on the heavy rail system.
Well, it was difficult on DLR when you had several situations like that, because it actually required quite a lot of integration. So you had the Lewisham extension, you had the City Airport extension, you had the Woolwich extension, and you had the core system. And because of the issues around that, in the end, ORR insisted that TfL DLR took over as the statutory ROGS infrastructure manager. And then each of the contractors, as you say, was responsible for the maintenance of their assets, but it was managed within the wider context, and that can be a problem with that. It looks good on paper, but caused problems, and led to the odd situation where the operator was the infrastructure manager for the stops and had to go to different people when the lifts were out of action. And DLR, of course, has traditionally been a very heavy reliance on, you know, they've always prided themselves on the availability.
May I ask a question, please? Or is Phil Ransom speaking? Good afternoon, all.
Who? Never heard of him.
Ransom's the name.
Hello, Phil.
Hi, John. Hi, John. Thanks. All good stuff. Have
you not heard this before?
No, I haven't. No.
Oh, right. Okay.
Okay, there we go. All good stuff, and some sort of good reminders of you know, things that have occurred in the past, and perhaps some of the reasons why they've occurred. And you know, it was interesting, you know, the comment just now. Well, what was the Maidstone East derailment? Well, if you've been at it 100 years like you and I have, then we know about that. But there's plenty of people in the industry who don't know about those sort of things. But there you go. But the reality is, a lot of our systems and processes and everything have all evolved because of these said incidents over time, and that's why we've got standards, that's why we've got rules, etc. And hopefully most of them deal with those risks. But it's understanding the root cause, I suppose, of that. I guess a concern I have, or a query, is how do we impart that knowledge? It's all very well knowing what you have to do, but it's far better to understand why you have to do what you have to do and what the root cause is. I don't know if you've got a view on that, as how we perhaps disseminate that information, and I think your talk is one means of that, is one means of educating people into why are we concerned about these particular issues. But just wondered if you had a comment or a thought.
Yes, it's one reason why London Underground reintroduced the track engineering classes, but also included peripheral people. So not just the people who are actually out and about on the track, whether skilled artisans, technical managers, but also included or encouraged office people to participate as well. So that means that people have the understanding, and of course it gets people talking to each other and sharing knowledge, and it's important to that's happening. And one advantage of Network Rail taking a fair amount of things in-house is that it should encourage that sort of interaction with each other, because one of the problems with Railtrack was that, first of all, they promptly got rid of all their own historic knowledge. And then there were issues between the people in the different contractors talking to each other. But you then had a problem in the early days of Network Rail where you had somebody from a manufacturing background where change did actually shake things up, and you did need to think about change regularly, as against asset management, where you're looking after assets that go back into the mists of time. I mean, there are still, on the London to Birmingham, there are still overbridges that, if they were not needed to be rebuilt for overhead electrification in the 60s, still go back to the original Robert Stevenson bridges. The stone flat arches at places like Coventry and Adderley Park that were clear of the overhead wires are actually original. And then, of course, you still have all the original viaducts. The things like Stockport Viaduct, which was widened, built in the 1840s, widened in the 1880s. You have to live with these. And we know masonry structures will last millennia, but it needs to be kept up. It's like in tunnels, making sure you understand what the water's doing. And on the Southeastern Division, many of you will be familiar with Sevenoaks Tunnel, where you walk out into the rain to keep dry because it's better than getting wet in the tunnel. Before the sheeting was put in there, it used to be a tunnel where the drivers I can remember cab riding going back to the 80s, and drivers putting windscreen wipers on there. Balcombe Tunnel on the Central is another one. And it's understanding what's happening with that, making sure that, and it's also having people understand what's going on. Tunnel engineers are amazed when I describe to them the original London-Birmingham tunnels, which basically are a ring without an invert that was basically put in to stop the rocks falling on the train. And there's quite a big annulus behind the ring. And I found those when I was deepening refuges for the advanced passenger train. I mean, that goes back a bit, but we were breaking up the refuges and deepening. And one of the things you could do was look along when we were doing 2 or 3 refuges and see all the refuges behind the ring. And the tunnel engineers were saying, well, how do you know this? And I'd explained it and said, but that's not how. I said, yeah, they found competent ground. They were worried about bits falling from the roof, so they put a ring in. I mean, Higham and Strood tunnels, for many, many years, they had no rings at all. It was just a railway through the chalk. Bearing in mind they were built as canal tunnels. Originally, the railway was on trestles through those 2 tunnels. Then it became a double track railway. But it's only in the last 10, 15 years or so that they've actually had a protection put in because the amount of chalk falling onto the track was too great, and having watchmen walk through a conductor rail tunnel to keep an eye open for it became a complete no-no. So, you know, you have to understand what's out there. It may bear no resemblance to what you have in modern standards. I was called out by a sometime colleague of ours to look at a problem he was having at a depot, and he couldn't work out what was going on with the bullhead track because the turnouts didn't seem to be quite right. And they weren't quite right because the crossings had bolted down noses. They were the old standard railway equipment crossings. But at some stage, probably when the points were powered up, they were replaced with REPW switches. So the switch panel was REPW, and the crossing panel was standard railway equipment, which is why they didn't tally as any known turnout dimension. Yeah, it's just the the giveaway was the bolted down nose, but these things survive indefinitely. I mean, the question I was asked, well, how do we get bits for this? And I said, have them go and grovel to London Underground, and they might make them for you at Lily Bridge.
Good point. Good point. Okay, thank you.
We just had a comment stroke observation from Peter, and it reads, collision and derailment at Waterloo a couple of years ago was a very similar event to the 1987 Clapham Junction crash. An observation was that the industry had forgotten the lessons learned. We always have to be vigilant to the loss of these lessons.
Yes, agreed. And that was a surprising one because my impression of control engineers is that those sorts of things are now driven into their younger people from the start, but clearly not in that case. That the goings on were quite remarkable and astonishing. You know, they were it was very much back to in fact, worse than the Clapham stuff, because some of it was more deliberate rather than, slipshod.
I think that was part of the problem, is that it's getting second generation or even third generation removed from these accidents, and the significance of these details is just lost on people these days.
Yes, I think that's a problem. It's just a quick reflection on where I am at Ricardo. The civil engineers, unlike the rolling stock engineers and the systems engineers, which have a complete range of generations, it's been very noticeable to me that when I joined, the civil engineering, the fixed infrastructure people were all gentlemen of mature years with grey beards. And, that's, I think, a reflection of the fact that particularly on the infrastructure side, there has been a tendency since the end of British Rail to go to consultants who, of course, are primarily projects functions rather than understanding the long-term issues you can have.
Yes, that's providing me with a bit of income at the moment through reteaching people lessons that have and stuff that has been lost by people moving on, and the skills not being passed on. So I'm fortunate in earning a bit of money and reminding people.
But it's also more of a problem to get people out, that you can't do what happened to me before joining the railway sponsored student scheme. I did what these days would be called an internship for a couple of months between, at the age of 18. And basically I was just taken out and about with the technical staff in the old Divisional Civil Engineers Manchester, and just picking up things by osmosis, as it were. I mean, okay, they let me play with levels and things like that and do drawings and stuff. But I don't think there was any expectation they'd get any useful work out of me, not at that stage. But at least it got you understanding what you were dealing with and going out, and that, you know, I did what then went for the PTS course before they took me out. It was nothing like you have now, but it did give, you know, it was going out and seeing the assets and seeing what, you know, how they interacted with the trains, and just seeing curiosities and oddities that people had to live with. Just isn't as accessible as it is now, and as it was, you know, right through the 80s into the 90s.
One could even say one could say it's even more important now, though.
Yes, it's just that the access is even more difficult than it ever was. And, you know, I gave up my PTS about best part of 10 years ago, because trying to keep it up with the amount of visits you needed to do was very difficult. But thinking about my days as a BR manager, yeah, I would just zip about, and I'd have a note of where different people were working and then simply drop into it with them. And that included doing it at nights as well. You know, dropping on the tampers, dropping on the welders, dropping on the ultrasonic detector operators, just part of what, you know, is called management by walking about. Yeah, and you know, it brings you up to speed with what they're up to, what their problems are, because artisan staff will think more readily about things if they're actually doing it at the time. You know, it's, you know, by the way, we've thought, you know, glad you've come, we can talk about this with you. And you don't get that when you pull them into off nights into a room and they're half, you know, half asleep because of the change in sleep patterns and everything. It's much better one person who's in a position to do something goes out and meets them in their work environment.
I think you're right. So I think you're right. I did a lot of that with when managing drivers. It was being out assessing drivers, and a good opportunity to chat about things, and they would tell you all sorts of things that you wouldn't get from asking them to pop into the office to see you. So it's very well worth doing as a managerial tool.
Yeah, well, it's like cab riding. You know, sometimes the problem when you're cab riding is concentrating on what you're there to do, because the driver's suddenly found a captive audience. You know, and
terrible, aren't they?
he'll be telling you all the problems, you know, all the way from A to B, whether it's sort of Birmingham to Euston, when at least I could switch off when we got to Rugby because it was somebody else's railway, or, you know, some sort of Victoria to Dover or whatever.
Yeah, bang the drum for the PWI. I mean, I think we serve two purposes. One is, you know, these kind of events, and you know, I'm delighted, absolutely delighted the Ashford section's going again, and it's good to see you guys having a meeting, and here we are passing on some good information. So hopefully some of this is soaking into people who perhaps haven't heard some of this before, which is superb. But the other thought is getting that access to see track engineering actually underway, and that's extremely difficult. I work in a design organisation now, so it's a, you know, it's a big event if I ever step on a piece of ballast these days, to be honest, or any of my team do. But obviously the PWI's track work challenge is one means. It's not perfect, but it's a means of getting younger engineers out to see, feel, hear, understand a bit about what track's about and how you put it together. There's massive learning in that, you know.
Okay, so John,
Colin,
thank you for...
have we dealt with all the chat questions?
Yes, we have indeed. They've all been covered very thoroughly. So thank you again on behalf of the Ashford PWI. Excellent presentation. And I think the Q&A session at the end was equally as informative. So yes, I'm going to pass over to Phil Edwards just to do the vote of thanks.
Yeah, okay. Thanks, John. Fantastic presentation. There's a lot of information. You really cantered through some of the some of the highlights and points of your career, and I was furiously writing down some of these points. You know, stretcher bar breakages on steel bridges, wheelchairs getting welded to the platform, hay falling on people,
No,
the
it was the
goalposts.
ramp. It was the
Oh,
ramp.
it was the ramp. Oh, not the wheelchair. Oh, sorry. Okay.
Yes.
But yeah, very interesting though, and yeah, and I mean the Mason East derailment. There was two things I remember about that. It was the steel coil that was everywhere on the platforms, tracks everywhere. I've never seen
Yeah,
such a dramatic derailment as that.
it was
And
a mess, wasn't it?
it was an absolute mess. And the second thing is that in my mind, that derailment was the catalyst for the drinking culture completely ending on the railways. You know, you couldn't drink on duty or go into work under the influence of alcohol before anyway, but there were a lot of people that weren't taking a lot of notice of that. And then when that derailment happened, that really did make a big difference to the culture and the change in the drugs and alcohol policy. So yeah, it was quite a famous derailment from that point of view. But John, you've covered a lot of ground, really have, on asset management, and lots of really interesting things, not just in the UK but overseas as well. And certainly I've worked with you before, and I don't know anybody else who's done as much expert witness work as you've done when I think about anybody in the industry. So you know, total respect for what you've done in the past and what you're still doing now after all these years, and the information that you've imparted to us. So big thanks, John, for the presentation, and thanks on behalf of everybody the Ashford section and those listening. So.
Thank you.